This video is going to begin to talk about ducts, particularly horizontal ducts. So this is where things start to get a little bit more complex. It's a lot like structural framing or bracing because it sort of just depends on the peculiarities of your own project. And you're just going to have to work through that. So what I'm going to do here is just sort of show you a few tips and tricks, what you should pay attention to when you're placing your ducts. And keep in mind, these are still schematic buildings, so if something's not perfect, it's okay. We can work it out later. That's the sort of stuff that gets ironed out. We just need to see that the first principles are thought of here. So I am in a ceiling plan of my ground floor, and I'm going to go to Systems and Duct. Now, there's a few things we have to pay attention to. First, under the modification pane here, we can see a width and a height. Now, you want to keep this as close to square as possible, but it is totally fine if you go up to a 1 to 1.5 or 1 to 2 dimensions. So this could be 18 by 36, but you want to keep it at about the same volume. So if your width is getting squashed, your height is going to have to increase to move the same amount of air. A 36 by 36 here represents a good main duct run. It's a large amount of air for a building of this size, and so it can be tapered off towards the end. But if you drop down here, you can actually find a few sizes, so you don't have to necessarily type it in. I don't really know why they do this, but it might be convenient if you don't want to constantly have to type it in. Anyways, the next thing we can look at is the middle elevation, but rather than change this, let's go ahead and look at some of the properties here. First is the constraints. So this is going to be the horizontal justification, whether we're placing it on the left or the right. This is the same as the walls, so if you're placing it on the center line, it's probably the best way to work here, especially if you're working with grids. The vertical justification might change, however. So what I recommend here is changing this to the bottom, which means we're going to be placing the bottom of the duct at this reference level. And you want to change this to probably one of your plenum levels. This is one of the main reasons we created plenum levels. So here I can change it to level 2 plenum, which is the level, the plenum below level 2, right? It's a little bit confusing, I guess, in the nomenclature, and you might have it different. But just pay attention to some of these things that change here. So all of these sort of adjust to, based on the justification here. So the bottom, I would change this to 0. And you'll see all of these adjust accordingly. So the top elevation is going to be basically the height of your duct. So that will be 3 feet. And your bottom elevation is at 0, but it's being placed at the plenum level. Let's go ahead and place one of these ducts here. You can see it starts to want to snap to things. So if you have grid lines, then that will be useful. But let's take a look at how this placed. Now you can see that the use of multiple views is going to be really important here. So that's why I showed it in the last tutorial, because you're kind of going to have to go back and forth. You can also use a section box. So if you turn this on, if you turn the scope box on, that is a section box. It might be hidden, so you have to turn your scope box on. So I'm going to unhide and view by the category here. And then we can turn our scope box to none. And now we have what's called a section box. And we can push and pull this. And this will allow us to easily see what's going on inside of our building. So here you'll notice that this duct was placed and it's inside of the beam. If we go to a north structural view, an elevation, and let's just hide the walls, you can see this is the duct, right? We placed it with the bottom on the level 2 plenum. Now the advantage of placing this on a level that it's on its own is that we can place the air terminals here, but we can also just move this level down. If you don't want to do that, you can also go to your 3D view and use the align command. So that's AL, or you can go to modify and align. And you can choose the bottom of one of these beams to align to, and then you can select the top of the duct. So that's a really quick way to make your your ducts align. Just know that when you move the level now, this will all move with it as well because it has an offset. So you just have to pay attention to what you're aligning and what you're moving. So keep that in mind as you go through it here. Let's take a look at a few other things. Let's go back to systems and duct. You also want to pay attention to the system types. So you have a few system types here. We're really just focused on return and supply. Next semester we'll get into fresh air and exhaust air. But just keep track of what your supply and your return ducts are classified as, because that will allow you to easily change this in a second, which I'll show probably at the end, so that we can see these as blue and our return ducts as pink. Let me go ahead and change these dimensions to 24 by 24, and again we can drop down here, just change it to 24. And we're still placing it at the bottom elevation, referencing level 2. And now we have to pay attention to how these things are going to connect. So I'm just going to place one here. This would be a secondary run, and then I'll have others that will probably tap off of this. Let's again go to a 3D view. But you can see that because I had aligned this and I hadn't aligned this, that there's a little bit of a disconnect. So it might be best to align things afterwards all as one. Or you can just move them one by one. So I'll go back to the align here, and you can see this fitting here. If I select it, it's takeoff. It's actually tapping into the duct, and so that has to do with how these ducts are working together. We don't really have to pay attention to that, and you can also use tees, but tees would basically put a fitting here at many instances, but not all. It doesn't really matter. Whatever you get to work, use that method. So again, we can align this, and here you can see that this is a successful sort of tap off. Now, this can't be below or above it, so you could adjust the center. You could align the center to the center of the duct as well. And again, just pay attention to how you're placing these things, and then align them later. This is really usually something that's sort of gone through many times during the construction or the development of the building, because beam depths will change, duct sizes will change, normally get smaller. But let's go and place one more element here. Let's say I want to turn this into this chase. Now, it wouldn't go here because this is an opening for my fire stairs, but just as an example, let's actually put it at the edge here. So you can also use the align tool to align the edges of the ducts, or if you don't want to do that, you can select the duct and you can extend it and it will snap to where it needs to go. So there's many ways to do it. You can also right click the duct and create similar, and you'll see that it will sort of populate here. But now you can see that this is producing what's called an elbow, or a connection, and the reason that it did that is because this was placed at a different place than this was aligned to. So we'll always try to adjust to where you're going. If we look at a 3D view here, oops, I have my section box on, so I can't really see it. But there we go. You can see that it would fit up into this beam. So just pay attention to when you're aligning things. Again, that's probably the most important aspect here. You might want to just align things all at the end once you realize that their beams are there. You can also change these, so you can change the top elevation to 0, and it will sort of try and adjust, right? It will keep this at the top, but then it will tell you whether this disconnects or not. So there's many ways to influence these things. So the last thing I'll show here is if we wanted to curve this beam in. Again, I'm going to right click and I'm going to create similar, and I'm just going to draw this here. Now this is what's called an elbow, and we can change this if it's too small. If this isn't working, what I would do is do something similar to this, where you just extend the beam, or sorry, you extend the duct and you directly tap into it. And that's actually pretty common, that it has sort of a depressurization zone, so that it balances out. But this is common as well. Now to change this, what you'll have to do is you'll actually have to edit the type, because this is a family. This is a duct fitting family. If we're in a mechanical plant or a mechanical file, we would have many of these loaded in, but we don't. So we need to edit this, and I'll show you what you can change this as. We need to duplicate this and call this 1 times the radius. So the radius multiplier will be changed to 1, and then you can see this is a much less, it's a much smaller radius. And 1 is pretty much the lowest you can go for these radius, and this is just going to help you if you have a column here to get around that column. And again, you can also totally avoid this by just pulling the beam forward and tapping directly into it. And this is actually fairly common where you have a little bit of extra room here. So those are all of the things for horizontal ducts. The next tutorial is going to go over vertical ducts and chases, and then we're going to talk about supply terminals or air terminals, and also focusing on how to connect the ducts to the mechanical system, or the mechanical units, the AHUs, which tends to be quite a struggle. And again, if you're struggling with this, just try and get these to schematically work. Just push the ducts into each other, and eventually we'll have something that's representative of our mechanical system.